And it looks like we were correct. The answer here is 9x squared plus 12x plus 4. And so we have here, this is a perfect square trinomial where each side length is the same. And in this case, 3x plus 2. Okay, let's talk about number 6 here. The area of a rectangular lot is represented by the area 6m squared plus m minus 35, and it gives us a side length. The width is 3m minus 7. Find the length. We do not know what the length is. Alright, well, what occurs to me is that we can just take 3m minus 7. Oh, incoming phone call. That's funny. Hold on. Okay, took care of that. Put out a little fire right there. Okay, there's our pen tool activated. Alright, let's finish this up. There's our rectangle with an area of 6m squared plus m minus 35. They gave us a side length, 3m minus 7. Find the other side length. Alright, well, let's see here. What we would normally do is we would take 6m squared, if we were to factor it, plus m minus 35. We want to figure out what the factors are. Well, they already gave us 1, 3m minus 7. Okay, well, 3m times what is 6m squared? Well, 3 times 2 would be 6. 3m times 2m would be 6m squared. Okay. Alright, now let's figure out what two numbers multiplied together equal negative 35. Well, let's see here. We know that some factors of negative 35 could be 1 and 35, 2, 3, 4, 5, and 7. And that's it. Well, I'm guessing that we're going to need to use these factors right here. Well, our 7 is already there, so let's just write our plus 5 right here. And let's FOIL this and make sure that it works. So 3m times 2m is 6m squared. Okay, good. 3m times 5 is plus 15m. Negative 7 times 2m is negative 14m. And negative 7 times positive 5 is negative 35. So let's add like terms. 6m squared plus m minus 35. Bingo, we matched it. So the other side length is 2m plus 5. Okay, let's keep on trucking to number 7. Scroll bar, scroll down. Ooh, multiple choice. The polynomials 2x squared minus 5x minus 12 represents the area of my bathroom. What are its dimensions? So it's basically asking you to factor this. So if you wanted to, you could FOIL every single one of these answers until you get something that looks like that. That's your fallback. But what we're going to do is we are going to actually factor it. 2x squared minus 5x minus 12. Okay, so we're going to use the method, the algorithm we learned in class. Let's take 2 times negative 12. So 2 times, that's a little x for times. 2 times negative 12 is negative 24. What two numbers multiply to negative 24 but add to negative 5? Well, let's see here. Factors of 24 are 1 and 4, 2 and 12, 3 and 8. Ah, right there, bingo. 3 and 8. We can get 3 and 8 to add up to negative 5 because negative 8 plus 3 is negative 5 and negative 8 times 3 is negative 24. So there are factors. We'll write our skeleton, x and x. X minus 8, x plus 3. But since we timesed by 2 up here, we now need to divide by 2 down here. Divide by 2. divide by 2. And now don't forget this step, we need to reduce. Okay, so let's reduce. So this would be x minus 4. And now we can't reduce this anymore, so we can immediately swing on this step. We'll take that 2 and we'll place it right there in front of the x. So 2x plus 3. So there's our answer. Let's look for our answer. 2x plus 3, x minus 4 right there. C. Oh, these are fun. I like these. Okay, let's go down to number 8. Come on, come on, come on. There we go. What are the factors of the expression? Blah, 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 blah. Okay. Let's see here. What color? Oh, so many colors to choose from. Let's do this one. Okay, 5x squared minus 17x plus 14. Okay, okay, okay. So, what we'll do is we'll start off how we normally do. 5 times 14. I don't even, what is that? It's 120, 140, I think. Is that right? Let's see if I'm right. 0, 2, 5, 6. Oh goodness, I am not very smart. 5 times 14 is 70. So we need to figure out what factors of 70 add to negative 17. Checking out our answer choices here. Here we go. I bet it's 10 and 7. So a negative 10 and a negative 7 would multiply to 70, but they would add to negative 17. Where do we get this 70 from again? Remember, 5 times 14 is 70, and this negative 17 is what we need. We pull it, it's the middle number right here. So now that we have our factors, we can put them in our skeleton. X minus 10, x minus 7, since we multiplied by 5 at the outset. Now we need to divide by 5. So let's divide each one of these by 5. Divide this by 5. Now we will reduce. And so that would be x minus 2. And 5 does not go into 7 evenly, so at this point we can swing that. We'll swing that 5 right in front of that x. 5x minus 7. There's our answer. So x minus 2, 5x minus 7. Here it is right here. Answer choice B. Okay, let's come down here for 9. What are the factors of this expression? X squared minus x minus 72. Okay, well notice there's no number in front of this x squared, so this is a much easier example for us. We can go right to our skeleton here. We can go x and x. So what two numbers multiply to 72? Multiply to 72, but add to negative 1. Oh, Mr. Russell, where did you pull that negative 1 from? Right here. This negative x, there's like a 1 right in front of this x, if you want to think of it that way. So I'm thinking through my times tables, which I have dutifully memorized, and I'm thinking of a times table, negative 9 times 8. Negative 9 times 8 is 72. Negative 72, and negative 9 plus 8 is negative 1. So negative 9 plus 8. And here it is right here. And now, of course, remember your fallback is you can just go through and FOIL every single one of these if you want until you get the answer that matches this. Okay? Great. 9 is in the can. Let's keep going. Number 10. More factoring. Okay, let's see here. What are the factors of the polynomial 2x squared plus 5x plus 2? Oh, the factors. So what we want to do is we need to figure out two numbers that multiply to 2 but add to 5. Well, let's see here. The factors of 2 are 1 times 2. And that's it. When 1 plus 2 is 3. So I can tell you that we cannot think of any numbers that multiply to 2 but add to 5. So guess what? Prime. This is a prime. This polynomial is prime. There are no real solutions. No real. I think you can write something like this.